Hello, this is Nicholas from Silicon Chip Publications, and I wanted to talk to you today about the articles in the October 2025 issue of Silicon Chip magazine. Here's the cover, and you can see we have an article about autonomous vehicles, digital preamplifier, a dual train controller, workshop vacuum controller, pendant speaker, and others. So let's have a look at the contents. So you can see our first article is the autonomous vehicles. It also talks about um, driver assistance systems. Then we have an article on Home Assistant, which is a home automation software, and that was started last month in the September issue, and this is the final part that talks about some more advanced features of Home Assistant. Then we have an article on how to buy secondhand speakers, what to look for, which speakers are good and which are not. We have an article on an old radio, the Reinhart's 2 tuned radio frequency receiver. And then we have our four projects, the digital preamp and crossover, which is one of the most advanced projects we've ever published, and that's in several parts. This is the first part. Then we have a vacuum controller, which is used for workshops to collect dust automatically when tools are used. We have a wireless battery powered model train controller, which is an add on for a project we published in the January issue. And we have the second half of our pendant speaker article, which is an interesting kind of speaker because it's the first time we've published a do it yourself speaker article where it hangs from the ceiling. And we have some other things in the magazine too. We have an editorial mailbag section with letters from our readers, Circuit Notebook, which has a circuit that somebody sent in, Serviceman's Log, which is about repairing equipment, and then Ask Silicon Chip, again, more letters from our readers, but this time with questions. Let's have a look at the first article. This is the one on autonomous vehicles, and it talks about the history of the autonomous vehicles, meaning vehicles that can drive themselves, which goes back a lot further than you might think. And then we talk about some of the systems that are used: LiDAR, ultrasonic sensors, radars, cameras, that sort of thing. Some of the software that's used. It's This article is aimed at the general public, but it also goes to fairly in depth with the technology that's used in these vehicles, including software and hardware. So that's an interesting article, I think. Moving on to the digital preamplifier, as I said before, this is one of the most advanced projects that we've published. Involves a lot of digital processing. So we can see here, this is the preamp. It has four analog inputs, some digital inputs, and also some analog outputs. And as well as being preamplified, this can also be used as an active crossover. So you can program the crossover, for example, because it has multiple outputs. You can have one output only delivering treble, one only bass, and one mid range, and that way you can run them into separate amplifiers for driving the speaker drivers without needing a passive crossover. And that gives you a lot better control over what frequencies go to what drivers, uh, and it can provide much higher sound quality. But you don't have to do that. This can also just be used as a general purpose preamplifier. Here's the block diagram that shows how the various parts join together with this ADAU 1467 DSP at the core, and that does all the filtering and routing and volume control and that sort of thing. That's the DSP chip there. It shows how it's been soldered. And then we have the circuit, which is broken up into, I think, 8 different chunks because it's quite complicated. This is the analog switching. The analog inputs are selected by relays after the RF filter and coupling and so on, buffered by these op amps, and then fed to the monitor output as well as to the DSP. The ADC that feeds the DSP. Here's the actual analog to digital conversion. So the analog inputs go through these filters and into this chip, which converts it to digital data that's fed to the DSP. Then we have some digital switching and so on. And then this is the DSP chip, and that does, as I said, pretty much all of the audio processing. But that's not the whole story because it needs to be controlled and programmed, and that's done by this microcontroller here, which also handles user input. There's an LCD screen, there's a rotary encoder, there are buttons and so on. That's shown separately. And then over here we have the DACs, digital to analog converters, and there are four of these in the preamp. So the four stereo outputs are each driven by their own DAC. There's a muting relay there, and the DAC gets their data from the DSP, which stands for digital signal processing. We also have this not optically, actually, it's capacitively isolated interface for a USB board, So that provides high quality USB audio input and output. So that can also be used as an input and output on the preamp. And then here we have the control. So we have an infrared receiver, rotary encoder, buttons, and that connects to this header that goes to the microcontroller. The power supply is split into two pieces. This is the separate power supply board that takes the output from the transformer, rectifies it, and it produces a 5-volt digital rail and plus 10 and minus 10 volt analog rails. And then if we have a look here, there's an onboard power supply on the main board that then takes those supplies and further filters and regulates them, and also includes some switch on, switch off reset logic here, so that you don't get clicks and thumps and so on when you switch the preamp on and off. And here's a preview of the PCB circuit board. It's a 4-layer board, and because it's 4 layers, that means we can have a power plane, a ground plane, and 2 signal planes. And that makes the routing of the signals much simpler, and that also means that you're going to get better sound quality because the connections can be direct, they don't have to cross over, and the planes also provide shielding. So this is the part 1. It's covered basically how it works, and then part 2 and 3 are going to be about building and testing and setting up the digital preamp. So a very nice project there. And then we have our Home Assistant article. As I mentioned earlier, last month we introduced Home Assistant and talked about how to set it up and use it, as well as build a satellite that connects sensors to it. But this follow-up article has information about things like connecting cameras to Home Assistant, temperature logging, using it as a thermostat to switch something on or off depending on the temperature, also backing up the settings, and various useful things to know about Home Assistant. Then we have our vacuum controller article, and this is the vacuum controller, and it's a system. So the idea is that one of these units can control a vacuum for one appliance, like a saw or a drill or a lathe or a mill. And the idea is that when you switch that appliance on, it will automatically switch on the vacuum, and it will keep it running for some time after you switch it off, and then switch the vacuum off. And it can also, because you might have one vacuum that goes through multiple tubes to vacuum up the dust from multiple tools, it will also switch what's called a blast gate, which is like a kind of a valve that lets the vacuum suck up dust from different routes. So it will open the blast gate for the appliance that's activated. And if you have multiple appliances, you can build multiple of these and join them together through these modular sockets here using standard cables. And that way, they can all control the same vacuum, and it can figure out how to route the sawdust and the air. So here you can see the mains outputs. So your appliance being your tool, like a saw, and the vacuum are powered from here. And then you can see here how you can join multiple together. So only the first one controls the vacuum. Each additional unit is just there to supply power to the tool, sense when the tool is running, and then it sends a signal back to the main unit to activate the vacuum, and it also controls the blast gate if you have that. So a very flexible system here, relatively straightforward circuit. There's a little bit going on. It has to sense the current to know when the tool is running, so it uses a current transformer for that. It also has an onboard power supply. This is the circuitry here to convert the output of the current transformer into essentially a DC level that it can use to tell if the appliance is on or off. And then we have power sharing and interlinking for multiple units, and the blast gate control down here. Here's the circuit board. Because it's modular, you can build the board without certain sections, so that's why there are dashed lines to show where the components in each section. And for example, if you don't need blast gate control, you just don't have to put these components on the board. This talks about how the AC signal from the current transformer is rectified to DC using an op amp. And here we have information on cutting out the case and mounting the various connectors and so on, fitting the PCB in the case, attaching the light pipes to the LEDs so you can see what's going on, some labels for the lid, the wiring diagram here. And so it's a self-contained article here, all the parts. And so it's a little bit complicated because some parts you might or might not need. So they're broken up into sections so you can decide that. That's the vacuum controller. Then we have this article on buying secondhand speakers. And it talks about what to look for and things to avoid and so on. A general article can be handy. You can get some bargains at charity shops and so on if you know what to look for. And then we have our dual train controller. So we have circuit here. We previously published a battery powered train that had a single remote control for a single train, and this expands the system to add two controls, a single transmitter that can control two different trains on a model layout. So here's the receiver and charger that are the same that we published before, just with slightly different software, so that the transmitter can distinguish the receivers. And we have all the wiring details there, the parts list and so on. And then we have the second part of our pendant speaker that mainly concentrates on building it. So it's made from I think it's some kind of a recycled plastic pot that you turn upside down, put a panel in, cut some holes out for some drivers. And it's a relatively straightforward assembly. Paint it black to make it look nice, add some wadding, add a very simple crossover, and you have a pretty high performance ceiling mounted speaker that sounds better than most commercial speakers, unless you spend a lot of money. And then the last article I'm going to talk about today is this vintage radio. So this was actually a kit radio that was published in Electronics Australia some time ago. And it's a pretty simple circuit, but it talks a little bit about how it works. And that's pretty much it. So as I said, there are other articles in this issue, but that's all the major ones. So I think it's a pretty interesting issue, and I would like to get some feedback from people on what they think about this digital preamp, because it's obviously we have a range of complexity. Something like the train controller is pretty simple, but the digital preamp is a pretty complicated and advanced project that I think is potentially very useful if you're into hi-fi. So thanks for listening. Check out the October 2025 issue of Silicon Chip. It's now on sale, late September 2025, in Australia and New Zealand newsagents. You can subscribe to it through our website, and there's also an online edition available worldwide. Thanks for listening.